Hello, 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 hello. Hello to everyone. So today's lecture is going to be focused on very fun and challenging questions. And you guys are going to, trust me, learn a hell lot of things from today's class. And I want you guys to stay focused, get prepared while watching this video with a notebook and a pen and a scale and a pencil. So four things you should have handy before you start watching this video, and just one thing that would just elevate your experience of learning altogether is when you do simultaneously with me the questions. And if you, in the cases that you already know the answers to the question, you can just skip that particular portion and move on to the next question, because I assure you by the end of the class there are really fun and challenging questions that are actually going to make you one of the perfect, and let me repeat, perfect at the conceptual understanding people in solving inequalities using number lines and just inequalities in general. So let's dive straight into one of the questions that I had given in the previous lecture as a homework. So I'm going to solve that question for you guys, and I'm sure that most of you would have already solved it. So let's just, okay, there's some problem with my pen tab. Oh, there's no problem. We are good to go. Okay, let's check. How do we solve this question? We take like terms on one side of the inequality and the numbers on another side. So constant and variables on the opposite side of inequality. Always remember. Okay, let us do that. What is this going to be? X minus 5x is greater than equal to minus 11 minus 1. Okay, I hope by this time all of you already know how to do it. And if not, I would suggest you to go and watch my previous video, that is lecture 2, and then jump on to this video. Okay, so you have here minus 4x, which is greater than equal to minus 12. Now there is negative sign on both the sides. So it is going to be eliminated. We have x is greater than equal to 4 divided by 2, 12 divided by 4, which is 3. And how do you plot it on number line? Again, a very good concept that we learned previous lecture. That is, first we make sure that this number actually exists and we note it on number line. Okay, so we have 1, 2, 3, 4, and so on. So I made sure that I write 3 because there is 3 in our inequality. Now there is an equality sign, and just a quick recap, if there is an equality sign, we have close bracket. That is, we have colored, right? The dot. So it's not hollow, it's filled. And x is all the values greater than or equal to 3. So it goes beyond 3, right? So this was the solution. And if I write it in another way, it is going to be 3 is included. So close bracket, and it goes to positive infinity, and therefore the bracket is open. Okay, let's go to the fun questions. Now, this might seem a little bit tacky for you guys, but I assure you, by the end of the lecture, this is going to be one of the simplest questions that you deal with. Okay, fractions. No need to be scared of fractions. Let's choose one side and deal with it one time. Okay, so let's just choose this side. You have minus 2 is less than equal to half minus 2x over 3. Now, this lecture is going to be actually a little lengthier, but I would suggest to pay attention because I've come up with a lot of challenging questions. The denominator is not common, and that is kind of a problem for us. So step 1, denominator has to be the same. So we use cross multiplication method. We multiply 1 with 3 and 2x with 2 upon we multiply the denominators, right? Okay, so what does this give us in return? Minus 2 is less than equal to 3 minus, remember this is not multiplication, but this is 2x multiplied by 2, which is 4x upon 6. Now 6 is a dividend for the entire, it is getting divided by it. So we need to take it on other side. It goes on other side becoming multiplication. And then we just have normal algebra. Okay, so we take it another side, which is minus 12. Minus 3 is less than equal to minus 4x. Okay, what do we have here, students? I hope you have your pen and paper and you're doing it simultaneous with me. So you have minus 15 is less than equal to minus 4 of x. Now minus and minus gets cancelled because it is on both sides. So you have 15 over 4 is less than equal to x. Let's just divide it and check what do we have here, students. So we have 4 ones are 4. We have 4 threes are 12. We have 3 carry and 0. So 7s are and then 5s are. So you can just cross verify the division by yourself. So we have x is actually open mouth is towards x, so greater than equality 3.75. Okay, let's go back to a question for a while. What kind of values can x take? X can take natural numbers. Is 3.75 a natural number? This is question 1 to you guys. And if you don't know the answer to it, I would suggest that you guys revise a little bit basic of what is natural number, what is whole number, what are integers, what are rational numbers, what are rational numbers and what are real numbers. Okay, okay, let's jump back to it. So x is anything greater than equal to 3.75. This is one of the major equations that we have gone. Now we jump towards the next part. Now, while jumping towards the next part, make sure that you already have this common denominated fraction, which is nothing but this portion, right? So I'm going to write that as it is, that is 3 minus 4x upon 6 is less than equal to 1, 5 upon 6. Now, how do you solve this? We know it very well. So let's quickly get into the solutions of x, which is less than equal to 6 ones are 6 plus 5, which is 11 upon 6. 6 is divided on both sides, so I am very nicely going to reduce it. So it's cancelled. And now what do I have, students? What do I have? I have 3 minus 4x is actually less than equal to 11. Okay, now this has gotten to a very simplified equation for us. See what we had in the very beginning and what do we have now. So everything that looks really horrifying is not actually horrifying until you simplify it. Okay. Um, Let's take like terms on one side and x on another side. So we have minus 4x is less than equal to 11 minus 3. We have minus 4x is less than equal to what is 11 minus 3? That is 8. So what do we have? X minus x actually equal to 8 upon 4, which is 2. So we have minus x less than equal to 2. Now you'll ask me, why, ma'am, did you not take minus 4 in the denominator, but just 4? Why did you keep minus in left hand side? The reason is I want to show you a very important concept that students usually forget while solving inequalities because they have only equality in their mind. So we are very accustomed to solving equality questions, but inequality is quite fresh to us genuinely. When we take negative sign from LHS to RHS or vice versa, what do? We switch the inequality. So now this is actually x is greater than equal to 2. Okay, now we have two equations and we need to represent it on number line. It is again very easy for you guys since you have been doing it for the past lecture. Okay, so we have what? X is natural, remember guys. So x can be, can x be 3 is my question to you guys. You have to look at both the inequalities and tell me, can x be 3? Yes, x can definitely be 3. Can x be 2? Yes, it can. Can x be 4? Yes, it can. Can x be 3.75? No, it cannot. Even if it is a solution, you need to pay attention that x belongs only to natural numbers. So the domain is only natural. Hence, it cannot be 7.5. This number line task is do it by yourself. And if you have any questions, feel free to ask it on comment section and I'll be answering to as many questions as possible. Let's jump back to even challenging question where we are going to learn a little bit about sets and what is union, what is intersection, what is complement. Now we have clearly two number lines. We have been denoting from the following set of notions, that is this and this. Okay, so one is hollow and one is circled, dark circled, right, filled with color. This means included, and this means that the number itself is not included. This means there is an equality sign, and this means that there is not an equality sign. Now, we're going to use a different notion, but the concept still remains the same. So there's no need to get really confused about it. So if we have a straight line, it means it's included. And if we have a curve, it means it's not included. This is actually same like this brackets. You see this brackets has a curve and this bracket has a straight line. Now let's jump back to our question. Now that we are familiarized with the notion, the question here says that for A and for B, we have different values of x. So for A, what is the value of x? X can be -2. Notice, it can be -2. So there is an inequality. Sorry, there is an equality at -2. And what is -1, 0, 1, 2, 3, 4, 5? Are these values greater than -2? Very definitely, 100%. So x is greater than -2 for sure. What about 5? There's a curve at 5, that means it cannot be 5, right? And it has to be less than 5. So my x is less than 5. This is my solution. I hope this is clear. If not, we'll move to B. It will, I guess, make it more clearer for you guys. Okay, the inequality is at 3. So x is definitely less than 3 and there's no equality because it's an open bracket, this sign. Okay, and there is a closed bracket at 4, sorry, -4, and there is equality for sure. Now, -3, -2, -1, 0, 1, 2, and 3, all the values that x is taking, is that greater than -4? Yes, and therefore, minus, greater than sign. Okay, now that we have A and B, we have already set builder notations, right? For A and B. Okay, so what is actually A? A can be all values from -2, -1, 0, 1, 2, 3, 4. Can it be 5? It cannot be 5. Nice. What about B? Okay, I want you guys to do the same for B together. Okay, let's take 2 seconds and think what can B. Okay, so it can be -4, -3, -2, -1, 0, 1, 2, and what about 3? It cannot be 3. Why? Because there is no equality sign. So it can be less than 3. Okay, now we already have A and B. Now we need to represent the following. We need to represent the union and we need to represent the intersection. It is very important for us to understand this concept. Now, let's suppose you have this two sets. Okay, so this is A and this is B. So you have two sets. This is A and this is B. What is A intersection? Sorry, what is A intersection B? Intersection. So such values that are also of A and that are also of B. Where do they collide? So in this case, this is the place they collide. So this is nothing but such values. Those are also in A and also in B, right? So this is nothing but A intersection B. Now let's try to understand union, the difference between union. What is actually union? Union means all the values of A and all the values of B. So basically we have all this, right? Even the intersection, because intersection values are also in A and also in B. So this is the entirety, and which is what? A intersection, union B. Now, what is complement? What is B complement or A complement? Let's try to understand these notions very well. B complement means such values, those are actually not B. So what are the values that are not B? Everything here, right, which is not B. Okay, I'm so sorry because, okay, yeah. So everything here, right? Everything other than B. So this. Also this, right? Also A. Now what about A intersection B? What do you guys think? Will it be included in B complement? That is everything except B? No. Why? Because A complement B, A intersection, I'm so sorry, A intersection B actually involves B. Okay. Now that we have understood B complement, A complement, and other stuff, it is time we'll move to our question. Because today's focus is challenging questions with conceptual clarity. And that is why I gave you a little bit preview of what it actually means about the complement. Okay. So sorry. Okay. Let's go towards our first question. And the first question is A union B. That means all the values of A and B. Okay, let's see. What all values A is taking? It is taking -2, -1, 0, 1, 2, 3, 4. So from -2 to 4, all the values. And what about B? From -4 to 2, all the values. So when you add all of them, you're not actually adding the elements, but you're telling the range of the elements that it can take. So A can take from -2. Okay, I think we should go back to our, yeah, here. So A lets or allows X to be all values from -2 to 5. And in B, it allows X to be all values from -4 to 3. So their intersection will actually allow all the values from actually -4 to 5. Okay. Now, you need to understand about the signs. Okay. Is -4 included either in A or B? Yes, there is a closing bracket. So when you draw the number line, you need to pay attention that you make the closing bracket at 4. So at 4, the bracket should be closing. Okay. And at 5, what happens at 5? Sorry, -4. What happens at 5? At 5, it is an open bracket in A, right? And in B, it was not included, but in A, if it was included, that we're going to take the extreme limits of it. And the bracket is going to be open. So this is how you represent it on number line. Okay, let's quickly try to do it together for A intersection B complement by understanding what is actually A intersection B complement. So B complement are all values, those are not B. Those are not B. So B is actually taking all the values. B is actually taking all the values from here to here, right? So we want all values, those are not that. So here, let's compare it with A. Was A taking any value from -4 to 2? -2? No, it was not. So it will still not be there. Will not be adding new elements. We are only dealing with the elements that are in A and B, okay? And in B, is it taking the value 3? No, because there is an open bracket. In A, is it taking the value 3? Yes, it is. Definitely. So, what is your intersection? Oh, sorry, what is your intersection going to be with B complement of A? It's going to be all the remaining values of A that are not in B. So these values. Let's try to write it. What is going to be our A intersection B complement? it is going to be x belonging from 3 close bracket to 5 open bracket. And on number line, it will look something like 3, you have 4, you have 5, and on 5, you have open bracket, and on 3, you have close bracket. Okay? We're going to solve more questions like this for better clarity, like this question. Okay, what is this question? Let's see that A and B, you have two sets, and we have to represent on different number lines A intersection B. Okay, let's represent A intersection B. Okay, let us quickly see the limits. When I say limits, I mean to say what values can x take and what are the extreme values on left hand side and on right hand side. Okay, so what are the values? Here, x is going maximum -1, sorry, maximum 5 and minimum -1. Here, minimum -4 and 3. So maximum is actually 5 and minimum is actually -4, right? So I'm going to have something like -4, -3, -2, sorry, -1, 0, and then I'm going to go all the way up to 5. I hope this is clear. Now, next, I have an equality at 5. I have an equality at 5, and I don't have an equality at -1. Okay? I don't have an equality at -1. So the green actually represents all the value of A. Now let's see B. Okay? B represents from -4, there is an equality. So it's going to be straight. And at 3, there is no equality. So like this. And this is actually what we have for A and B. Very quick, very easy on one number line, right? And now we need to understand what is A intersection B. Okay, let's try to understand what is A intersection B. What is intersection? Such values that are both in A as well as in B. What values are in both A and B? Something where green and yellow lines collide, right? So somewhere from here to here, there is an intersection. Now, what are the values of intersection? So here there is an open bracket, here there is an open bracket, right? So this is going to be your number line for A intersection B, -1, 0, 1, 2, and 3. So this is going to be your A intersection B using number line. Okay? So we see where they collapse, where they collide together. Okay. Let's jump to next question. This is going to give you more clarity. Come on, students. These are such good questions for concept learning that before examination, they are like must go to do kind of questions. I assure you, if you do them, it's just going to benefit you. Okay, we have two sets. We have P and we have Q. So we are going to sort them differently. Okay. Now let's see. And X belongs to real. Okay. Let's see what P solution gives us. Now we know that like terms we have to take it another side. So 7x minus 4x is actually 3x. I'm eliminating steps for your better understanding because we need to start doing some things mentally for faster calculation. But remember, accuracy is equally important. Okay, greater than sign remains as it is. -2 goes that side. So it becomes +2. 1 plus 2 is actually 3 and you have x greater than 1. So this is your P. Your P is actually solution. So x is greater than 1. Now, what is your Q? Let's quickly do it as well. We have 9x minus 45 greater than equal to. Now, 5 is multiplied by the entire bracket. So let's just open the bracket. We have 5 x minus 25, right? Okay, so 5x goes this side, becomes 4x greater than equal to 45 goes that side. What is 45 minus 25, children? Quickly, you guys tell me. Is this 20? And x is actually greater than equal to 5. So you have two solutions, P and Q. First one says, asks for, in fact, their intersection. So let's try to draw their intersection, students. I hope you guys are doing it with me because it is very important that you try questions on your own while following the lecture. Okay, so you have 1, you have 2, you have 3, 4, and 5, and 6. Okay. And here you have -1, -2, -3, and so on. Okay, quickly let's draw for x greater than 1. X greater than 1, open bracket, and all the values ahead. Okay. Now x greater than 5. X greater than 5, students, but equal to. So this is a straight line which is included and greater than. So all the values. What is the intersection? Where are these two lines actually colliding with each other? It is from 5 onwards. So your P intersection Q is actually what? Your x is greater than equal to 5, right? Because 5 onwards, even this Q has values and even P has values, right? Okay, let's students quickly go back to P minus Q. Okay, P minus Q. Now again, you have P, you have Q, and you need to understand what is P minus Q. So I'll draw the Q again. This is your Q. Blue is your Q. So this is Q. P minus Q. So you have bigger set P, and from P you need to subtract Q. What are you left with? You're actually left with this region. I hope you guys can also picture it, because from only in this region you have subtracted all the Q values. So what is actually P in P my sorry. Okay, what is actually P minus Q for you guys? It is all the values of x which are greater than 1. But there is one limitation, that it cannot be equal to 5. So x is less than yeah, x is less than 5, right? And this is actually P minus Q. Okay. Here there is no equality because the bracket is open. Here there is no equality because 5 is included, but it is included in Q and we need to subtract the entire Q. I hope that makes sense for you guys. Let's go to P intersection Q complement. Now Q complement. What is Q complement? Something that does not involve Q. Now Q is the blue region and P intersection Q complement is nothing but this region again. Right? Intersection of P starts from 1 to infinity and Q starts from 5 and it includes 5. So all the values less than 5. So this is actually the same thing for P intersection Q complement. I hope this makes sense. Let's quickly move to next question. Okay, I think I'm going to do this in two parts. So this next question we're going to do from the next class onwards, and you guys can, I'll just give you a preview of the questions we're going to do because really interesting and important questions. So we're going to do questions where there are different kinds of R or different kinds of X. So in the previous question, X was actually belonging to real numbers. There was a question where X was actually belonging to natural numbers. There was a question where X was belonging to whole numbers. And we also did a question where X was belonging to integers. And here we're going to see a little bit of combination of all of them. Okay? Yeah, of all of them. And moreover, we're going to do some questions which are about positive odd integers and some questions which are about even. So we are actually going to cover X belonging to variety of domain. And it is super important to understand how domain plays an important role for different types of solutions. So these are the questions that we're going to begin in the next session. And I hope you guys are already ready for it. And just go through the questions one more time. And if you have any doubts, any queries, more than welcome on our channel. You can ask me anywhere, anytime. And till then, I hope you guys practice, 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 and get ready. If you have any questions related to how you should approach a certain type of question or what should be your strategy in the coming next few days, I would suggest you to watch my lecture on the strategy because it is going to give you some really valuable insights to how to deal with the coming days. And good luck as usual. All the best. Bye bye.